Hello and welcome to Hearing Your Future, the Coding Your Future podcast. My name is Duncan, I'm your host, and I'm on a mission to help you design, build, test and code your future in computing. In this podcast, we'll talk to current and former students of computer science to find out more about their journey from student to professional. What's their story? How are they coding their future? What obstacles have they faced and how did they overcome them? Finally, we ask our guests what advice they'd offer their former selves and fellow students, and where are they headed next. My guest today is Cristian Bodnar. He graduated with a Bachelor of Science degree in Computer Science in 2018 and did summer internships at Improbable in London and Amazon Web Services in Edinburgh.
Cool.
Welcome, Cristian. Could you start by saying a little bit about who you are and where you're from?
My name is Cristian Bodnar. I'm a senior researcher at Microsoft, and I'm originally from Romania, and I also graduated from Manchester in 2018.
18, so 5 years ago now.
Yeah.
Right. Okay. Good. Thank you. So, what I want to do today is capture a little bit of your story from starting studying computer science even longer ago, eight years ago now, and then your journey to where you are now in a short space of time. So can we start with right at the beginning, what was it that made you want to come and spend 3 years at university studying computer science? What was it? Was there a particular thing that made you want to study computing at university?
Yeah, I mean, I still remember when actually John Shapiro interviewed me for Manchester. I don't know if he remembers, and he asked me like, okay, why computer science? And I remember answering him that you have the opportunity to kind of be multiple persons in some sense. So I've always been a generalist, and I thought, okay, you could do many things with a computer. Like you could be a biologist if you really like, you can do computational biology. You could do mathematics, like all kinds of mathematics are done now with a computer, right? You simulate things, you have all these things like simulations that are kind of not analytically tractable. So pretty much anyone works with a computer, in any field, and at the end of the day, you could be a problem solver, you can do algorithms and all these kind of things. So yeah, it really was kind of, for me, the easiest way to do a bit of everything, really. And,
right. Okay.
Have the chance to do a bit of everything later on once I finish the degree.
And I guess you'd studied it in high school, so you'd had a reasonable amount of exposure to it in high school in terms of, not just theory, but a bit of practice stuff as well, a bit of engineering as well, I suppose.
Yeah, I was quite deep into the kind of algorithms and competitive programming.
Right.
I think many people coming from Romania will relate here.
So like Olympiads, that sort of thing?
Yeah, both mathematics and also kind of informatics and
right.
I think lots of algorithms in general, and I really like that, and solving problems with using computers and so on.
Good. Okay. So you arrived here in Manchester 8 years ago, and you got to the end of your first year. I think were you looking for? Did you do a summer internship in your first year, or was it something that happened a bit later?
Yeah. So in my first year, after my first day intern at Amazon in Scotland. This was quite funny because I knew I wanted to do an internship, but like all the applications were kind of we don't accept first year students.
Yeah.
And including the Amazon one, they explicitly said that, and I was like, okay, I'm gonna apply anyway and see what happens. So I did, and then they interviewed me, and that went pretty well, and then they made me an offer. And later that summer I found out that they got some applications from first years, and then they said, okay, maybe let's prototype this, see how it goes.
Right.
So you never know where to expect an opportunity to arise. So I think something I learned from that was just try your luck anyway, even if kind of break the rules, and because they're kind of arbitrary after all.
That's good advice, actually. So I think as a problem I see in a lot of first years, the question I get asked most is like, I can't find an internship because it all says like penultimate year only, but actually sometimes there's no harm in applying anyway, and you might in your case you got lucky, I guess, with Amazon. So that was Amazon in Edinburgh, was it? And what was that doing in Edinburgh? Were you?
Yeah, they were, I think the team I was in, they were having like kind of a recommendation engine for Amazon, basically kind of recommending you products, you might want to buy and things like that, which is, how they make a lot of money. And I was in this team, which was quite interesting because they're also doing machine learning, which, was kind of, I guess, less hype than now. It's kind of a bit more the early days of deep learning and so on. So it was quite cool to see, how they were actually applying it at scale and doing all these things. And I think I also learned a lot, just in terms of software engineering. I realized later on when I was doing the software engineering course in the second year, I think, how little I knew. Like I had no idea what an integration or unit test was, and I think I was just kind of asking around. I think I was maybe a bit scared to ask questions that summer, maybe also because of how little I knew. But I think since then I learned it's actually so very important to just kind of be relentless with asking questions, even if you're annoying.
Yeah, actually, I'm trying to find a picture here. There's a picture of you. Let me see if I can find it. I think it might have been in your first year when you did there was a BBC Barclays.
Oh yeah, the University Challenge.
Was that in your first year?
I think it was the first year, as far as I remember. Yeah.
So you were part of a team. I'm just trying to find the picture here. You're part of a team that there it is. So that would have been about 2015, I think. So that would have been in your first year.
I think it was winter or spring, maybe 2015, something like that.
And you did a challenge at the BBC where you had to propose. I don't think it wasn't much engineering involved, was it? It was more of a proposition that you.
I think kind of making some sort of design for an app. I think it was for the Summer Olympics.
Something probably related to iPlayer as well, or something like that at the time. Yeah. So that was 2015 with those people sat on the bench there. So that was in first year. You did your internship at Amazon. You came back. You were studying software engineering. And I think you did I think so initially you were on industrial experience, weren't you? And did you transfer? You figured, right? Like if I can get good experience in the summer, you don't need to do a whole year.
Yeah, exactly. That was my
graduate
reasoning,
quicker, which is pretty good way of doing it. So you did another internship at the end of second year as well. Is that right?
Yeah. So next summer I interviewed with Improbable, which is this. Well, at that time it was like relatively small startup, or maybe medium sized, let's say, in London, doing large scale simulations. That was quite interesting. Also, I think the kind of interview stage for that summer, I think that was quite difficult. I think after the summer at Amazon, maybe I got a bit arrogant. I was like, okay, it's gonna be easy, kind of, you kind of rely on your past success and you assume it's gonna happen again. And I interviewed all the big tech, including Amazon again, and it didn't go well. I was kind of getting quite annoyed with how things went. And then I kind of realized maybe I should have prepared better and all these things. So I think I was kind of a bit overconfident after the first summer.
Right. And was it sort of technical interviews or behavioral interviews that you were struggling with, or?
Yeah, I think maybe a bit of both. Like I think it's just I didn't treat it seriously enough, the preparation, because I just assumed the same as last year will just happen. I mean I did prepare also the year before, but I think not as well the next year. And I think you do need to at least solve a bit of competitive programming problems to get back into shape and all that stuff, and kind of be in that mindset, know how to import these libraries quickly, these dictionaries or whatever you need to work with, and and so on. So you need to get these things kind of quickly implemented, and I think I was a bit rusty in terms of that.
Right.
I think I must have interviewed like more than 30 companies or something, right. And I still didn't have an internship. And then I started kind of getting more serious about it and preparing better, and then I had these interviews with Improbable, which I think went really well. Was also some of the hardest I had. Like all their engineers were like kind of ex-Googlers. It was very much like a Google culture you could see from just visiting the offices, and I think it was some of the toughest interviews I had. Like almost an entire day of interviews. I was just dead when I finished. Yeah. But it went extremely well, and actually they just called me on my way back from the interview that they want to make me an offer, and right. I kind of felt it's gonna happen now. And I think it was really, really cool. Also to kind of experience the startup life. I think it was very different from Amazon, of course, and I would say I liked it more just because I'm interested in not just the tech side, but also kind of all these leadership, business things, and it was interesting to witness the kind of decisions they have to make that you don't have visibility into in a company of the scale of Amazon. And then next year I also interviewed with them again, so I got the returning offer. And yeah, it was also shocking to see how much the company grew as well in the span of 1 year. It was much bigger company the next year from the year before, and I think, I don't know, number of employees must have doubled or something, or at least it felt like. So yeah, it was quite interesting.
So that was after you graduated, that one. You did one in the second year and then one at the end of the year when you graduated. But before that, you did a project with John. I mean, you mentioned John Shapiro there. So you did a third year project, and I think, did you propose your own project, or was it something you had an idea of something you wanted to do, and you machine learning, and you proposed the project to John, or was it one that John had proposed?
Yeah, I proposed my own project. I can't remember. I think I had some original proposal. I can't remember exactly what it was. I think probably I've done that before the third year, somewhere like before the summer.
Yeah,
because I think that's when you have to do it. But also I wasn't, I guess I was busy with other courses, so I'm not sure if it was the best proposal. But anyways, John was happy with it, so he took me. And then I think over the summer, I started reading a bit more just to figure out what exactly I'm going to do next year in terms of the project. And then I think I grew more interested in other kinds of things. And yeah, I talked to John, and I think I switched my project to like this text-to-image synthesis project, and using GANs, so generative adversarial networks. These were still kind of the early days of deep learning, so to speak. I mean, maybe not quite the early days, depends, because I guess some people started 3 years earlier, but like it felt like, I think, definitely not as hype as it was now, and actually I used my money from the Improbable internship to buy like an expensive GPU, because I knew I'm not going to get any from the university. So I just had this computer just for that project. And yeah, I mean, it was
just one GPU, right?
Yeah,
I'm not talking like lots of GPUs.
Yeah, it was just one, but it was a pretty powerful one. I think it was kind of one of the best you could buy at the time.
NVIDIA or...
Yeah. I think it was like a 1080 Ti. Actually, I'm trying to sell it right now. It's been kind of staying in my office in Cambridge, unused for a while. Yeah, so...
I know you actually got a paper out of that, didn't you? Get some there was something, you had something in Archive or something.
Yeah, I put it up on Archive. I think it was pretty much state of the art, I think, at the time. I think, unfortunately, I think I could have done a bit more and maybe published in a workshop or even a conference, but I was so unexperienced that I had no idea about these options. So that's maybe something I regret slightly, because it's just on Archive, and I didn't do any effort to publish it.
But you're not to know at that stage. I mean, one of the questions the talk you were just doing earlier, students were asking this question about publishing, and it's quite difficult at the beginning, because you don't really know what you're supposed to publish and how you publish and where you publish and who you can publish with and all this kind of stuff. And so it's not in hindsight you can see, I could have done a little bit more work and got something a bit more out of that. But I mean, it's impressive that you got anything out of it, because a lot, getting something out of an undergraduate project is good.
Yeah.
So you did your, you graduated. This is 2018. You've done this internship going back to Improbable, and I think by that time you decided you wanted to do a PhD. So what made you think? I mean, was it kind of doing researchy stuff that made you think, actually, I really enjoy the research side of things, I'd like to go on and do a PhD?
Yeah, I mean, I think this project I did really got me into it. I mean, I knew I loved machine learning, and also as part of the project I was just reading lots of books on my own and papers, and I think also for the same reasons I really like computer science. You could do a lot of everything in machine learning, also more advanced mathematics as well. I was also quite interested in mathematics, so it felt like kind of a nice way to combine all these things I liked even more. Also I got this undergraduate awards prize for that third year project, so that kind of encouraged me as well. Okay, I was on a good track, it was some good work. So then I went to Cambridge for an MPhil in advanced computer science.
So at that point, this is kind of like as I understand, the way the MPhil program works is that you can kind of, if you decide after a year, actually, I don't want to do research, you can sort of leave at that point and go and work somewhere. You've got an MPhil, you've got a qualification, or if you are, if the PhDs or the research is going well, you can carry on and basically do that, turn that into a PhD, or carry on in the same vein to do a PhD. So you you did a proposal for your MPhil project. Is that right? So part of the application process is pitch us your idea of what you'd like to do your research on. So was that was machine learning related at that point? I think saying you picked a supervisor. So rather than just writing a generic proposal, you said, right, I'm interested in the person who became your PhD supervisor, I think, was it? Or was it somebody?
Yeah, so I think actually I haven't, that was what I was recommending the students earlier, because that was the mistake I did. I actually didn't do that. So I can't remember actually what my proposal was, but I'm pretty sure it was pretty general. Like I didn't do any research, as far as I remember, into like potential advisors. So I just kind of proposed something that came to me. I don't know what it was. And of course I wasn't necessarily paired with the right advisor because of that. But yeah, kind of during the year, once I was accepted, I switched to Pietro Lear, who's been my MPhil advisor and then PhD advisor later on. And yeah, I think we were getting along very well. He also gave me a lot of freedom. So yeah, I think, I kind of changed my direction later. And I think you always have that freedom with this proposal. So, no one kind of constrains you to do exactly what you said you're going to do, but it's a pretty good filter for who you're going to be matched to. So, at least in terms of broad interest, it would be useful, if you actually match with the right advisor.
Yeah. So, so the MPhil you do, is it 1 year of the MPhil and then it's another 2 years for a PhD, or is it another 3 years?
3 years.
So you do 1 year of MPhil and then 3 years of PhD after, right? Okay, so then you start your PhD after that. So what was your PhD in? What was say a little bit about what your PhD was in?
Yeah. So again, I think, looking backwards, I'm amazed how
Which
these organized,
you got
I guess.
last year, didn't you? So it's 2022 is the date on your thesis. Is that right?
Yeah. I submitted it in December 2022, and the Viva was in February this year.
Right.
So and officially I got
you passed. Congratulations.
Thank you. And officially I got it like a month ago or something.
Right.
The actual diploma.
Right.
But yeah, like looking backwards, I think even with the PhD proposal, I think I just proposed some sort of extension of my master project, just because it was easier to write something on you knew about. But I didn't like that. It was published. It was my master project was published at AAAI, and it happened in New York. That was kind of the first conference I could attend, and the last for a while because then COVID hit and there was no conferences. But it was I think it was like right in February before COVID or something. So that was great.
So you got the first taste of going to a conference.
Exactly.
In New York, and it was a good conference to go to. I imagine.
It was amazing. Yeah,
huge conference as well.
So I think I proposed an extension of what I did in the masters. But again, during that summer, I think I was at Google X in California between the masters and the PhD, and I was working on like machine learning for robotics. I think it was one of the best summers of my life. Like you would just deploy your machine learning model on an armed farm of robots, and they're running your software. That was kind of amazing to witness, and I was just watching them all day, how they pick up things, trying to spot differences compared to previous models. Is it doing better at picking this subject than other object? So that was pretty amazing. But I think it also kind of made me realize maybe I should do something else for the PhD than what I proposed originally. I'm not sure if I took my own proposal very seriously anyways, because I think I knew I'm going to be accepted in the program, because I was quite highly ranked in the MPhil. So, and I think also that summer in my spare time I was watching this course on geometry and topology from this mathematician Tadashi Tokiera. He was a professor in Cambridge for a while, but I think he left before I arrived there, and now I think he's in US somewhere. I think might be at Princeton or something like that. And he has like these amazing YouTube courses on geometry and topology, and he's not just kind of a good teacher, but he also kind of gets you excited about the subject, not necessarily just about what precisely he's teaching and the way to think about mathematics and so on. So that got me very passionate, and then Pietro's group was doing lots of graph neural networks, and this was kind of.
Can we backtrack a little bit? So can you tell us what a graph neural network is? I guess most people listening to this hopefully know what a neural network is, but how is a graph neural network different from other kinds of neural networks that people might be familiar with?
Yeah, I think these days people see it as part of this bigger field of geometric deep learning, and this is kind of where this connection with geometry and topology came in. So in some sense, you can have data living on all sorts of geometric objects like surfaces, like if you're in 3D graphics or something like that, you have lots of data kind of living on, I don't know, also animated things or things like that, meshes, but also on graphs in particular. For instance, could be one type of geometric object where you can have data on, and it's quite common. Like if you have a social network, Facebook is doing all sorts of machine learning on graphs because all their data is based on graphs and so on. So basically it's a model for processing data that lives on graphs and all sorts of statistical tasks involving graphs. And there's also you can also see it as some form of discrete geometry in some sense. Like if you see the graph as a discretized geometric space, if you want, and this gives you many connections with geometry and topology. And I think that was kind of my unique perspective into this. And I think at the time maybe not many people were sharing this perspective of graph.
So you're bringing some of the sort of more theoretical aspects of topology and geometry into what is quite an applied area of computer science, isn't it? So it's kind of bringing those two parts together.
Yeah, exactly. Yeah, kind of. I was trying to connect the dots between the two, but ultimately also to kind of lead to some practical advancements for the kind of problems people are interested in, and I think to some degree I managed to do that. Like some of the work I published during the PhD, for instance, was applied to molecules, for instance, for predicting properties of molecules. I know, for instance, some pharmaceutical companies were looking at using these models. I think it was kind of mildly successful in also kind of getting some of this stuff into actually applied things that ultimately work. But at the same time, it was also an opportunity to do quite a bit of theory, get more deep into the maths and so on.
Yeah. So good, a nice balance of both.
Yeah.
There's another thing, you mentioned Twitter. Was it Twitter Cortex? Is that right? So did that come after Google X, or was that before Google X?
So I need to figure out. So I think my first summer during the PhD, I went to Google Brain. So when I was at Google X, I worked a lot with Brain people. They were kind of very close cooperation between the teams, and that got me under their radar, so to speak. And I knew people already, and I wanted to kind of come back and work with them the next summer. So that's what I did. Unfortunately, it was also the first summer under COVID. It was kind of a depressing summer, to be honest. Like I was supposed to go to California,
and you're stuck at home in
London, in a tiny apartment, and all my team was obviously in California, so there was like huge time zone difference. I had to work kind of more in the evening.
Right.
That was kind of depressing because that was kind of like a very short time span where we would actually overlap in terms of time zones and we could communicate. And then at some point I also had like a third advisor. I had two advisors from US, from Google, and a third advisor from Europe. So it was kind of also harder to coordinate with so many advisors. So, things got worse quite quickly. But we still published the paper at the end of, it was not my best paper, I would say, but, I think, it turned out into something.
And I guess in a way, some kind of good to... So you were saying earlier that you did these internships during your PhD, and you were lucky in that sense. You had it didn't have to be something directly related to your PhD. A bit like undergraduate internships, you can just go off and do whatever you want. But that was quite good because you were able to do different things throughout your PhD, just to kind of, I guess, kind of break from doing research, but was related to. So those came about. You were just applying for them while you were doing your PhD, basically.
Yeah.
Okay. We're now. So you graduated. Well, you graduated from the PhD last year. I guess have you had the big graduation ceremony yet? Have you done that with a gown and the cap?
Yeah. So that was a month ago. Yeah.
So you've already done that. You've done all that, and then you now work at Microsoft Research, which is based in Cambridge. So how long have you been at Microsoft?
Yeah, so I've been there since late March this year. Yeah.
And you're continuing doing, obviously we can't appreciate there's things you can't talk about what you've been doing, but continuing the stuff that you've been doing in your PhD in a commercial environment.
Yeah, I think it is tangentially related. It's not what I was doing specifically. I think it would be quite hard because there's many obscure things to some extent I was doing. So, but like I'm working on weather prediction and simulation using machine learning, and there's some of the best models out there in this space. They use graph neural networks. There's quite a bit of geometric deep learning. Obviously, you're on a sphere, because you could approximate the Earth as a sphere, and then you need to predict things on the sphere. So there's all sorts kind of related aspects with what I was doing before. There's also all these kind of differential equations that describe the evolution of weather. And I was also doing some work on these neural differential equations, how you can, during my PhD, on how you can kind of approximate solutions to these equations using neural networks. It overlaps quite a bit with some of these things I've been exploring.
So I guess one interesting thing here is, you mentioned the GPU earlier in terms of like access to hardware, right? So one barrier that people face in trying to get into AI and machine learning is that there's the theory part, but then there's if you're actually training models, sometimes you need, depending on what you're doing, you need access to quite expensive compute. So as a student, I guess you had access to good computational resources, but for undergraduates who are interested in getting in this kind of stuff, what would you recommend in terms of how they can get access to the hardware and GPUs or TPUs or whatever it is that they need in order to train and work on these models?
I think scarce resources in this sense was kind of also a problem. And when I was doing my third year project, and I knew I'm going to be quite, I'm going to work quite hard on this, and I knew, it's going to be, something I want to dedicate a lot of time to the third year project. So I decided to use my internship money from Improbable basically to buy a kind of a state-of-the-art NVIDIA GPU that I could have and I could just use for whatever. I think the reason I chose to do that, I think I was doing some calculation like how much would I pay AWS for kind of the same amount of compute, and I think I've reached some crazy conclusion. I would just spend those money maybe in a few months or maybe even less. It might have been weeks. So it made total sense, if you had I think 1.5K or something, the machine I bought, it made much more sense to just buy a machine and then you can use it the entire year. And I think even today, I know there's lots of research into large scale machine learning and so on, but I think you can do pretty well with one big good GPU, and especially if you kind of choose your problem set and what you want to work on quite carefully. I think that you can do a lot of progress, and you just have to be a bit clever about what. Of course, you can't produce GPT-3 or something, but there's lots of valuable research that can be done with just one GPU, and you can publish papers that use one GPU. And I mean, even during my PhD, I did that sometimes. I just had a lot of access to just one GPU, and just use it in smart ways. And
So the economics of that still stack up now? Is it saying that that still stands now? Is it sometimes it's the most economical way of doing it? Because the slightly scary thing about using these cloud services, whether it's the Googles or Microsoft's Azure or any others, or Amazon's, is that the bill can get quite big quite quickly.
Exactly.
So at least running it on a local machine that you've got, you're not going to run into any huge bills if you invest in a bit of hardware to start with.
And now the GPUs are kind of also even better, price, and is dropping, and you can get kind of the same power you could get a few years ago for a lower price. So that also kind of works to your advantage. And because if you want to do smaller scale kind of experiments, I don't think you need more compute now than you needed a few years ago. So but GPUs got cheaper, so I think probably that should work to one's advantage.
Good. Okay. So so part of the reason you're here in Manchester is you've done this talk on graph neural networks. So you've just given a nice introduction to graph neural networks and some of the stuff that you're doing at the moment. I guess you're saying there's work in progress there, that you're in the point of publishing at the moment. But if we could take a step back and go back to my questions. Sorry, I'm going to have to edit this bit out, but 1 second.
No worries.
Yeah, so we talked about a little bit about your journey from being an undergraduate, travelling, passing through your undergraduate degree, doing a PhD, and now starting your career with Microsoft. I want you to imagine that you've studied in two universities. Studied in the University of Manchester and the University of Cambridge. I'm now going to make you Vice Chancellor of either or both of those universities as you wish. As somebody who spent a lot of time as a student, as an undergraduate student and a PhD student and a master's student as well, what would you do if you were to be made Vice Chancellor in terms of making university more, better from a student experience point of view?
Yeah, I think something I found out all these years is that the best way to learn is to actually do things and discover things on your own. So I think a very nice way would be to have some program that is kind of teaching but research based, in the sense they have an opportunity to do some sort of research project. And I think there was even in Manchester, I think I was reading, I think when I was an undergrad, there was this, learning through research program, something like that.
Mm-hmm.
But I don't know how widespread it was, or at least it didn't affect me directly. And I think you might always have kind of opportunities, like local contextualized opportunities to do research on your own by working with someone, but it's not kind of institutionalized. Like it's not someone that everyone can have access to. So I think that could be quite useful to actually go to the boundaries of what's known in some particular sub area, right? And maybe discover it's actually not that hard, right? And I think that's kind of the best way to learn after all. Kind of like being an intern in a research lab at the university as a you did internships in commercial companies, but the same thing perhaps earlier on in the degree, because you didn't really get a taste for research until your final year, right? But you're saying it would be nice if you could do that earlier on, right? Exactly.
First and second year. I mean, I did that as an undergraduate, and it's something you remember years later. But so more opportunities to do that kind of thing, intern in research labs in the university before you graduate.
Exactly.
And not necessarily as part of an assessed piece of work.
I guess that's kind of optional. I think the main thing is to actually experience that yourself.
And I guess in your case, I mean, a good experience was because you wrote your proposal for a third year project, and that probably helped a little bit then when you were applying for master's programs where they're asking you to write a proposal, is that you've already had some experience of that blank piece of paper problem of what am I going to do, coming up with a good idea, pitching it to somebody,
and then you can also show that you kind of have a track record, you have some experience of of doing this, what it means to do research. It can be quite challenging at times, especially when things are not working and you don't have no idea why and things like that, right? So I think it can help a lot, especially if you want to have a research career afterwards, but not necessarily. Like it is a very different kind of experience from standard teaching, where there's always kind of a correct answer to anything. What's the right answer to that? Is like everything's kind of right or wrong, whereas in research it's you don't know, right? Like no one found out yet, so it's kind of a very different way of thinking about things.
So it's not just a technical challenge, it's more of a sort of cultural challenge of you're being an undergraduate or being a student is like doing what you're told, basically, kind of following instructions and ticking boxes, and then all of a sudden it's completely different doing research because you're having to come up with the ideas yourself and come up with good ideas and ways to test them. So
absolutely.
So when you were making that transition, actually, from being a student to being, a student who just studies to a student who does research, what were the sort of main challenges you faced in making that transition, and how did you overcome them?
Well, I think one is that your search space is huge. I think that's one challenge. You're one human and your time is limited and you could do anything, right? Like, and that's one of the big differences when you have like a particular teaching curriculum, someone puts this road ahead of you and you just walk. Whereas you have 100 avenues plus a few others that you're not seeing. So it's not clear in what direction you should go. So I think that's just kind of this huge combinatorial search space you want to explore, and with limited information about what each avenue will actually provide you. I think that's the most challenging thing, and I don't have a solution for that, if that's your follow-up question. I think...
I like what you were saying earlier, actually, about you. So someone was asking you after the talk about exactly that problem of, like, how do I write a proposal? And I thought your advice about start from the research papers, right? You can do it bottom up and start with the textbooks and try and understand the theory and build it up that way, but that'll take you forever.
Yeah.
So your advice to them, which I thought was quite nice, which was like, well, just read the latest research papers, and even if you don't understand it all, at least you'll be at the leading edge of wherever, whatever it is that you're interested in is at. So then you can write a better proposal, come up with a better idea than if you're just reading textbooks and stuff you've been told to read.
Yeah, I think it could give you a good glimpse of the destination that road can kind of lead you to, right? And you wouldn't know what to expect if you get there. You should, produce research of this kind. Does it actually excite you? And I think probably that's one of the best kind of filters. What actually gets you excited from all these potential things. If you read about kind of latest research in an area and you're like, then probably it's not the right one for you, But like, I think that's what kind of got me into deep learning. There was also these Atari papers that came out at the time, and also into kind of this text-to-image synthesis project. I think I really liked. You would be surprised by the thing you created. Like there's all this kind of generative AI that was, I was doing at the time. Like, you don't know what your model will generate, right? You'll be surprised by your own work, and that was kind of something that made me excited. Like,
right.
So I think that's kind of the key ingredient and probably the best filter to search through this space.
Oh, okay, good advice. Find something you're interested in, right? Rather than something. I mean, because there's a lot of stuff where when you see papers published, it's like somebody else is interested in this, and trying to make you interested in it and convince you that you should care about it as much as they do. And sometimes you do, but other times you just think, like you're saying, oh yeah, I'm not really not so interested in that. Okay, good. So there's two more things to finish up then. So the first one is one tune, one podcast, one book, one film. So I ask all guests who come on the show to recommend a tune, a piece of music that you, and we'll add it to our Coders playlist. So is there a piece of music that you'd like to recommend that people who listen to this podcast go and listen to, and say a little bit about why that piece of music is important to you?
Maybe I'll go with Do I Wanna Know from Arctic Monkeys, because I'm trying to play it on guitar. And it's the only song I can half play on the guitar. I started to, trying to learn recently, and that's kind of one of my first things I try, because I really like the song. So I'm going to go with that one.
Good, okay. Do I Want to Know by the Arctic Monkeys. There's a video to that with a sound wave. You've seen the video to it with a sound wave going up and down. That's quite a nice video. And then one podcast. I don't know if you do you listen to podcasts much, or or radio programs, if not, or maybe actually the way to cheat this is audio.
Let me get my Spotify. There's a few podcasts, but I don't know the exact names of. Let me see. Oh yeah, there's the Joe Walker podcast. Do you know that? Joe Walker.
No, what's that one? What's that about?
I think this guy he's from Australia, but he kind of. Yeah, and I quite like he invites very kind of diverse groups of people, like historians and economists, machine learning people. So it's like kind of a nice way to learn about all these kind of different areas. Yeah.
Joe Walker podcast. Okay, good. And then one book, any book, could be a novel, could be something else, non-fiction.
I'm reading now 0 to 1 by Peter Thiel. It's about building startups. It's quite interesting. I'll just go with that one.
So Peter Thiel's founded was he PayPal?
Palantir.
It was Palantir.
Yeah, and PayPal.
Was he
well,
PayPal before that as well?
Yeah, it was a PayPal before. Yeah.
Right. Okay, good. And then the last one is one film. Any film that you recommend? Favorite film? That's a harder one.
There's tons of them, but I'm gonna go with Gravity.
Okay.
Recently there was this 10-year anniversary in London at the British Film Institute, and Alfonso Cuarón came for a Q&A, and I was like in the first row, I really enjoyed rewatching it. And
did you get a chance to ask him any questions, or?
I did. To be honest, I was too shy to ask anything, anyways. But I was just kind of enjoyed seeing him answering someone else's questions.
Right. Okay.
But it was a great movie, so I'm gonna go with that one.
Good. Okay. And then the last one is time traveller. So my colleague in the physics department has invented a time travel machine, which they assure me works. And they've lent us. You can travel back in time to meet yourself in the first year, arriving here from Romania 8 years ago. What advice would you offer a younger Cristian about making the most of the short time at university? Because 3 years goes by very quickly, doesn't it? Even 8 years goes by very quickly as well. What advice would you offer?
Yeah, I think maybe. I think with hindsight, I realized, as we also kind of discussed, there were lots of things I didn't know at various stages on my journey, and it would have been nice to know. And realistically, I don't think there would have been any other way other than just talking to more people, maybe even outside kind of your immediate circle, or maybe just by expanding your immediate circle even, because by definition you can't think about things you don't think about, right? Like the only other way to think about these things you're missing, about the kind of unknown unknowns, if someone comes to you, right, and tells you about something you don't know. And I think that probably something I should have done more. I mean, I did involve a lot in, like also organizing hackathons and so on, and kind of met a lot of people, but I think I could have done more of that, maybe also in other areas, just to kind of learn from other people, what they're doing. Am I doing something wrong? Maybe, is it something doing something I'm not doing and I should be doing, and so on. And that kind of thing, maybe finding potential mentors, maybe, I don't know, talking to PhD students more or something like that. For instance, I don't think I talked to many PhD students when I was here, and I think I would have definitely learned something from that. You
probably had quite a lot of exposure to PhD students without realising, because they would have been TAs.
Yeah, exactly.
But
exactly. Yeah.
I guess it's hard to connect sometimes with people.
Yeah, that's true. That's true. Yeah. So yeah, I think kind of all sorts of things that would kind of diminish the unknowns.
Right. Yeah. Okay. Good. That's good advice. All right. So that's the last of my questions. So thank you, Cristian,
Thanks for joining us.
And I'll end the podcast there.
Thank you for listening to Hearing Your Future, the Coding Your Future podcast. You can find out more about this episode and all the other episodes, including full transcripts and show notes, at cdyf.me. That's Charlie Delta Yankee Foxtrot Mike Echo. You can also find us on all the major podcast platforms by searching for Coding Your Future or Hearing Your Future. Subscribe and listen wherever you get your podcasts. I hope you found something useful to help you start coding your future today.